Hello and welcome to the second lecturing on the module 5 of the gear trains. Okay. In the last class we saw what are the different types of gear trains and how to calculate the speed ratio in each of these cases. Okay. Today we will start by solving a problem. Right. So the first problem goes something like this. A motor shaft is connected to gear A and rotates at 975 rpm. The gear wheels B, C, D and E are fixed to parallel shaft rotating together. The final gear F is fixed on the output shaft. What is the speed of gear F? The number of teeth on each gear are as given below. Okay, so here are the gear, name of the gears and their number of teeth. Alright. Now in case of gear train, the problem is always asked based the objective of the problem is always to find the speed ratio. Okay, that is the ratio between the first gear to the speed of the ratio of the last gear. So and usually the number of teeth on each of the gears will be given. So similarly in this case also the same thing is there. Alright, so let us try to solve. Okay. So solution, this is a compound gear train. Okay, so from the sketch we know that it is a compound gear train, and also from the data given, the speed of gear A is given, which is 975 rpm, and then the number of teeth on each gears, okay, are also mentioned. So from this table, I can get these values. All right. Next, the speed ratio. So for a compound gear train, what is the speed ratio? The speed ratio is nothing but the product of number of teeth on each of the driven gear divided by product of number of teeth on each of the driver gear. Right? Okay, we know this. All right. So now we have to identify which are the driver gears and which are the driven gears. So let me first identify what are the drivers. So here in the first between the first shaft, gear A drives gear B. Okay, so A is the driver and B is the follower. Similarly, gear C drives gear D. Okay, so C is the driver and D becomes the follower. Then in the final stage, E drives F. So gear E is the driver and F is the follower. So accordingly we have identified which is the follower and which is the driven, and then next what to do is just substitute their values and then find the speed ratio, which comes to 18.5. Okay, so NA by NF, that is the first gear to the last gear ratio, is given by the sum of the number of teeth on the driven divided by number of sum of the product of the number of teeth on the driver. So you're going to get 18.5. And then you're supposed to find the speed of gear F. So speed of gear A is given, and I can easily calculate what is the speed of F, which comes to 52 revolutions per minute. Okay, so it's a very simple problem. Okay, next we have also discussed a little bit about the epicyclic gear train. Okay, see in all of the three types gear trains that we discussed, that is whether it is simple, whether it is compounded, or whether it is riveted. In that case, the gears, they rotate about a fixed point. The gears, they rotate about a fixed point. Okay, but in case of a planetary gear, all right, it says here, in an epicyclic gear train, the axis of the shaft over which the gears are mounted may move relative to a fixed axis. It may move relative to a fixed. It will rotate about its axis and also will move about a fixed axis. Okay. So in this particular example, all right, if I fix, so that is gear A, which is in mesh with gear B, and then A and B are attached by an arm C. Now suppose, think about it. If I fix the gear A, and try to give the rotation to B, what is going to happen? A is stationary, so B will actually rotate and it will move over the gear A. It will move over the gear A. So such a case or such an arrangement of a gear train is known as epicyclic gear train. So just like that you can see over here, gear B rotates about its center axis and also rotates over the gear A, or it also rotates about the center of the gear A. So such an arrangement is known as epicyclic gear train. Okay. So if the arm is fixed, the gear train is simple and gear A can drive B, or vice versa, right? In this case, if the arm is fixed, then yes, it is two gears will mesh and rotate. It will be a simple gear train. But But if gear A is fixed, then the arm is rotated about the axis of the gear A, then B is forced to rotate upon and around gear A. Okay, so that's what a epicyclic gear train is. Also, an epicyclic gear train. An epicyclic gear train is a gear arrangement consisting of one or more gears meshed around a central gear sun. The planet gears are fixed to a carrier arm designed to rotate on a same center as shown as the sun gear. The applications could be an automobile differential, watches, etc. What it says is, in this arrangement, we know that the central gear is known as the sun, okay, and the gears that rotate around them are known as planets. And the planet and gear are held together by something known as a carrier arm or a arm. Okay. Even in the example over here, the orange color gear is known as the sun because that is the center one, the central one, so sun. And then around them there are three smaller gears known as the planets. So you can say in this arrangement there are three planets and around a sun. Okay. Also they are held together by a arm or a carrier arm, that is this triangle over here, okay, on the ash color. So they are held together by a arm. And also in this particular example, on the outer there is an outer gear known as the ring gear. There is an outer gear known as the ring gear. Okay. Now another thing I wanted to observe is the direction. Okay, motion. Now when the sun is in mesh with the planet, okay, this meshing, this is the external meshing. So when the meshing is external, the direction of motion is opposite to each other. If the sun rotates in the clockwise direction, the planet will rotate in the anti-clockwise direction because they mesh externally. Similarly, if I take the motion from the planet and the ring, because the meshing is internal, okay, they both rotate in the same direction. In this example, the planet gears rotate in the anti-clockwise and also the ring will rotate in the anti-clockwise. Okay. See, we can observe in this particular example also, if the gear, the sun, this is the sun and these three are the planet and outside is the ring. So if the sun rotates in the clockwise direction, then the planets rotate in the anti-clockwise because they are meshed externally. Okay, and the planets and the ring gear are meshed internally, hence their direction is the same. Okay, direction is the same. In the third also here sun, the yellow color sun is the gear is the sun, around which there are three planet gears. Three blue one is the planet gears. So sun is fixed and the planet gears revolve around that. So if you see the motion between the planets and the ring, okay, is the same direction because they are meshed internally. Okay. So how to calculate the speed ratio for an epicyclic gear train? Okay, by the follower method. There are two types, tabular and algebraic. Okay, so in the tabular method, okay, you have to suppose you draw this table. Okay, we'll discuss this as we go further. Okay, but here usually the first step is to fix the arm and give one rotation to the sun gear. All right. Okay. Also, direction of rotation. Clockwise rotation is considered positive. Anti-clockwise is considered as negative. Okay, and when the gears meshed externally, they rotate in opposite direction, and when they mesh internally, they rotate in the same direction. We have seen this, right? Okay. See here. Okay. Then let us go to the first numerical. In an epicyclic gear train, an arm carries two gears A and B, having 36 and 45 teeth respectively. If the arm rotates at 150 rpm in the anti-clockwise direction about the center of gear A, which is fixed, determine the speed of gear B. If the gear A, instead of being fixed, makes 300 revolutions per minute in the clockwise direction, what will be the speed of gear B? Okay, so in this example, A and B are two gears, and this arm rotates about the center A. So A is the sun and B is the planet. Okay, so let us solve. This is an epicyclic gear train. Let us solve. So we know from the data that NA is teeth on gear A is 36 and teeth on gear B is 45. Okay, it's given over here. And then the arm rotates at 150 rpm counterclockwise direction or anti-clockwise direction. Okay. The objective, okay, is to find the speed of B by using the tabular method. Okay, how to do that? We'll come here. Okay, so first you are supposed to draw this box. Okay, where there are only three steps. Okay, but I'll come to the top row. So here conditions of motion you are supposed to write. Then arm, this is arm C. then gear A and gear B. Okay, gear A and gear B. Okay, that's all. So first comes the arm, then comes the sun, okay, and then comes the other gears. Okay. So here the first step is to fix the arm and give one rotation that's clockwise to gear A. So I fix the arm, so the speed of the arm is 0, and I have given one rotation to A. Okay. Now, then when I give one rotation to A, what is the speed of gear B? What is speed of gear B? So that is, now we know that A and B, right? If A rotates in clockwise direction, then what direction will B rotate? Because it is in mesh externally, it will rotate in the anti-clockwise direction, right? So hence the direction of B with respect to A is opposite, hence it is minus. Hence it is minus. Okay. Then this is equal to TA by TB. TA is the number of teeth on the on gear A, and TB is the number of teeth on gear B. How did I get this? Okay, I'll see here. Now, so we know that the velocity ratio between NA and NB. Okay, so NA is the driver and NB is the follower. So I can write that as NA by NB is equal to, is nothing but, because the simple gate train, number of teeth on the driver driven divided by number of teeth on the driver. So that is TB by TA. Or, okay, I want what is the expression for gear B, that is speed of B, NB. Okay, NB is equal to, okay, I'm rewriting this, TA by TB into NA. Okay, right? Now since NA is equal to 1, why? Because I have given one rotation. Okay, hence NB is equal to TA by TB. Okay, so that's what I have put over here. Okay, and this minus sign is because the direction is opposite. The direction to A is opposite. So that's all. So once you get this, the top one, everything is simple. Because the next step, step number 2 is what? Multiply by x. So multiply 0 by x is 0. Multiply 1 into x is x. Then multiply this expression by x gives me into x. Next add y. So I'm going to add y. So I'll get y. So add x to y is x plus y. And then add y means this is plus y, or I can write it as y minus this expression. Okay. So I hope you understood how you got this. Alright. And this also. Okay. Because it's the velocity ratio. Okay. Alright. Once that is done, the same thing will come here. This is the given. Okay. Now I can solve. Alright. The first it says that when the arm rotates at 150 rpm counterclockwise and gear A is fixed, what is the speed of B? Okay. Now this n arm, the expression is over here. This is for the expression for speed of arm. This is speed of gear A, and this is speed of gear B. Okay. So speed of arm is 150 rpm, but it is counterclockwise. Hence y is equal to minus 150. Okay. And speed of gear A, that is x plus y, is equal to 0. So I'm going to get 0. Therefore x is equal to 150. Okay. I got the value of x. Now, so then what is the speed of gear B? That is this expression. Okay, y minus TA by TB into x. I'll substitute the value of y and x, and I'll get the answer as speed of B is equal to minus 270. The meaning of minus 270 is it is anti-clockwise. Okay, if we get plus, then it is clockwise. So that is the speed of gear B is 270 rpm in the clockwise direction. The second it says, okay, if the gear A rotates in the 300 rpm clockwise direction, then what is the speed of gear B? Again, we know that y is equal to minus 150. Then x plus y is 300. Why? Because the speed of gear A is now 300 clockwise. Hence it is plus. Okay. Hence I'll get what is x. Then again for the speed of B, I'll again go to the same expression and substitute the value of y and x and get the speed of B as minus 510. Okay, so minus 510 means nothing but that's the speed of gear B is 510 rpm in counterclockwise direction. So we have solved. Please go through this problem one more time and understand it. We will solve more in the next class. Okay. All right. Take care.